Okay, good morning, everybody, wherever you happen to be on this morning. Thank you for being there. As I said before, it's a little bit chilly here in Adelaide. I'm sure wherever you are, it's quite cool, but we know that Claudia is in Darwin. So, yeah, a little bit jealous there. I'm sure it's nice and warm for you up there, Claudia. So, really good timing on the conference you went to, I have to say. We're really thrilled to have Associate Professor Claudia Szabo with us this morning. Her topic has obviously struck a nerve with our community as well as we have a great turnout. Claudia is a recipient of the 2024 AAUT Award for Teaching Excellence. So she's very much at the top of her game. And so this is why we invite our colleagues like Claudia who can really speak from a position of expertise on this issue. And obviously this is an issue that's really important to us. So thank you so much for being there, everybody. Couple of housekeeping things. For those of you who've attended before, you know we have a Q&A window. So during the session, if you could post any questions you have for Claudia in the Q&A window, feel free to talk in the chat as ever, but we'll focus on the questions at the end in the Q&A window. Please upvote any questions that you like, and I'll prioritize the questions at the end that have the most votes. And hopefully we'll have enough time to get through them all, but apologies if we don't. So before we get started, I'd like to acknowledge that I'm hosting this session from the traditional lands of the Kaurna people, and that we respect their spiritual relationship with their country. And I acknowledge the Kaurna people as the traditional custodians of the Adelaide region, that their cultural and heritage beliefs are still as important to the living Kaurna people today. And I also acknowledge the traditional custodians of the various lands that you may be joining us from today, and acknowledge the Aboriginal and Torres Strait Islander people who are attending. So I'll hand over to Claudia. I'll stop sharing my screen if Claudia, you'd like to begin sharing. And over to you, Associate Professor Claudia Szabo. Thank you very much.
All right, everyone. I hope you can see these slides.
We
Stuart, if you
can
can.
maybe, yeah, if you could
Beautiful.
full
Yeah,
screen them and then
absolutely.
we're good. That's great, Claudia. Thank you.
Brilliant. Thank you. And thank you for having me here today. I too would like to acknowledge the traditional custodians of the lands on which I find myself today, and these are the Larrakia people of the Darwin lands. As Stuart said, I'm in Darwin. I'm enjoying the amazing weather that is happening in here. But I want to thank you all for attending today's talk. I'll be talking about our approaches to mastery learning and what we've learned about models of mastery learning. And also, I think a topic that is definitely at the forefront of our learning and teaching practice, which is basically looking at generative AI and its impact on our respective disciplines. But before I begin, I'd like to thank AAUT for the award. And thank them for governing the award, for recognizing my work, but also really important for the constructive feedback and suggestions that I received. This wouldn't have been possible without the support of the teaching excellence team from the University of Adelaide, who have created an absolute fantastic array of avenues for supporting learning and teaching excellence. The School of Computer and Mathematical Sciences, and where I'm an associate professor, and the supportive learning and teaching culture that basically allows us to try a lot of new things, then to reflect on what worked and what didn't. There will be a lot of people that will be mentioned on these slides, and these are the amazing team at the University of Adelaide within the school. I'd also like to thank Professor Abelardo Pardo, who's the head of school for CMS, for having learning and teaching excellence at the core of his vision and supporting our culture. Now, my role within the School of Computer and Mathematical Sciences is that I'm the associate head for learning and teaching, and this means that I govern and I lead the learning and teaching portfolio for the school. It is quite a massive portfolio with a large number of students. Today, what I'll do is I'll be talking a bit about some as I said, some implementations of mastery learning within our courses. Then I'll give an overview of mastery learning models and what they look like, and then I'll have an overview of what our current thoughts are with integrating and bringing in generative AI within our mastery learning practice. So first up, I'll give a bit of a background about programming. So programming is the building block, is the key skill that somebody needs to have in order to succeed in the discipline of computer science and in the discipline of information technology. This is a skill on which a large number, not all, a large number of professions rely on. Anything from machine learning engineers to data scientists to cyber specialists, IT specialists, any of these professional roles rely on the fact that graduates and obviously students know how to program. And learning a programming language is a little bit like learning a new language. So you have to learn the syntax, and you have to learn the grammar. Now, most importantly, when you're learning a new language, you have to learn words, you have to learn the grammar, and you have to learn how to, through the grammar, how to put these together. Perhaps syntax, if you're not writing, is not that important. But different from learning a new language, when, for example, let's say you could go to a country from where you've learned the language and you could speak some words, maybe badly mispronounce them, point to things and just rely on people's kindness to help you through. When you are looking at a programming language, this is more of a binary skill. So either you can use the syntax and the grammar accordingly, and then therefore compile your program and run it, or you don't. So it is a skill. It is a foundational skill for which we require students to have mastery. So it's critical for them to do that. So within this space, our vision was that we wanted to make sure that we teach introductory programming in a way that allows students to master these critical foundational skills before they move on to more difficult concepts and to more difficult skills. We also wanted to make sure that our students are supported as they go through the mastery of these skills. And we also wanted to make sure that we allow our students the foundation and also the scaffolding to make sure that they can pick up additional desired skills easily. And for example, what this might look like is, let's say you've learned to program in a specific programming language, whatever that might be, C, Python, and so on, and you're looking at learning programming in a new language. Now, a lot of the things that make up a programming language, in particular the grammar, will be very similar across programming languages. So it's a easy skill, and it's an easy additional skill that can be acquired. Or maybe students would like to go really in depth about a specific programming language. So we wanted them to have these foundations, and then we wanted them to have the ability to build on them. So where we arrived from here was that we picked mastery learning as like one of our key pedagogical approaches. And within this framework, we're looking at making sure that students will practice skills with extensive support and extensive feedback, and that we allow students to move on to other skills only when they have demonstrated mastery in their current ones. We also wanted to be able to give students personalized support based on where they are in their journey of mastering these skills. I also had this vision of um, having concepts taught in a modular fashion, in particular, looking at allowing students to explore additional skills. So students would then take fundamental modules and any other modules that they might need based on either their professional desired professional role or based on their current interest or anything that they might find interesting at the time. So we're looking at, first of all, mastery learning. So having students mastering skills, practicing them, getting specific feedback depending on where they are, and also at having this modular plug and play structure. So there were, as you can imagine, there were a few challenges in implementing this vision into a university semester-based course. But we arrived at this, assuming we can click next. All right, yeah, we arrived at this at these implementation at this current implementation, which is what we have in our foundation courses within our master's degrees. So first of all, building on this idea of a binary skill, so that you either have or you don't have, these foundation courses are non-graded path. Um, this means, yeah, it's just a grading scheme. So instead of getting a mark, students either get a pass or fail. We broke down the specific content that we wanted students to focus on into modules, and we sequenced these modules accordingly based on the dependencies of the concepts within them. And this, I will say, this is fairly easy and straightforward and not contentious, although there are parts where we needed to have quite a lot of discussions. So it's fairly easy to do in a foundational course. It will be a little bit more difficult as you move on in the curricula. Students take tests at the end of each modules, and then they can retake the tests as they're going through to practice their skills. We had an iterative approach to the design of these courses. We looked at, as we implemented them, we gathered a lot of feedback from students, from course coordinators, from university support teams who supported students through these courses. We did a lot of tutor training with respect to focusing on mastery learning, focusing on making sure that students had the skills and that students knew what skills they needed to have. We also did a lot of sharing of stories of success with students, but also across the university. And this is because this perspective of a non-graded pass, of all of the modules and the tests that you could take as many times as you needed, was quite new for our university. Um, and as you can probably imagine, the first iteration of the courses definitely weren't at the top level of student satisfaction, but through that iterative process, where we looked at gathering feedback and addressing that feedback, obviously without changing and without compromising on our vision and on the key outcomes, has been quite good, as you can see. Really, the thing that I think speaks the greatest to the success of this initiative is that we could see a reduction in failure rates in subsequent courses. In the past, a lot of what we would see in the courses that follow this foundation and these foundational programming courses, we would see quite high failure rates because students would pass the programming course, but without really having the necessary skills to succeed in the very specialized courses that would follow in the masters. So this has been quite good to see. So this has been CS1, which is our first kind of course in a programming sequence. And as I said, it's fairly easy to order modules and to order concepts. It's also fairly easy to be able to say that that the skills that students acquire are binary, in the sense that they either have them or they don't. It isn't so easy within subsequent courses. So what you see in here is what mastery learning looks like in the next course that follows in this instance, and this is the current design of our object-oriented programming course within Adelaide University, design led by the amazing team formed by Cheryl and Billy and by everybody else who is supporting the course design and the quality review of the courses. So within this course, there are a sequence of concepts that students need to acquire in order for us to feel confident that they have acquired the skills to be able to succeed in subsequent courses. And these are given in here. You'll see them by these milestone tests 1, 2, and 3. In order for students to be able to sit these tests, though, they have to practice and master concepts, and this happens here on the left in the qualifier tests. But there's also a more refined and a more sophisticated understanding of the students' ability to apply the skills that they have learned. And they do this through the design and programming project. So really, these have been two examples of implementations of mastery learning. They wouldn't be possible without tool support. And this is because there is obviously the need for students to practice and to practice their programming skills in this particular instance. And there is the need for students to get feedback on their practice. Now, in here, we're looking at really fairly large courses. So as such, the need for an automated tool, both to generate a large number of questions, but also to assess a students' progress is needed. And I really very quick moment to just give a shout out to Prairie Learn. It is a really cool tool that allows people to um, design questions, automatically generate questions, put them in, tests, and obviously see student progress and as how they're going through it, through their tests. It is a tool that has been broadly used in STEM disciplines. I think initially it wasn't even actually implemented and tested for computer science. So I figured it might be useful for anybody who is working in this space. We're also looking at exploring this idea of a testing center. So in here, we're looking at having, and this testing center is obviously supported by Prairie Learn because it allows students to book into tests and have tests or take tests whenever they can in a secure manner. So these are some of the other things that would be needed for this. So looking at these two implementations, what we wanted to do next is we wanted to see how effective mastery learning can be in the era of generative AI, what models of mastery learning are out there beyond the ones that I've talked to you about, and what are the institutional support structures and what are the institutional roadblocks that would be put when one is thinking about implementing mastery learning. So this is a photo of us at a Dachstuhl seminar last year. We're all of us very happy living the life in the German summer on the steps of the castle. This QR code should take you to the seminar report as well. So we started in thinking about mastery learning by also thinking about what the student experience is within both the courses that implement mastery learning and the courses that don't. And this is a sculpture that is in Triet, which is a city next to Dachstuhl. And I think it really captures what sometimes our classrooms look like. So, we have some really engaged students in the first row there with their roles, I assume, but we also have a student on the side who's either not engaged, he or she is either saying goodbye, maybe that's his or her lunchbox, and they're going out and doing something. So we really wanted to capture this idea of the fact that through mastery learning, we're definitely seeing significant increase in student engagement as well, and this is one area where generative AI can help. So what we looked at in this work is for a sequence of courses, so moving beyond the CS1 and CS2 that I've showed you before, so the introductory courses, but going through like a computer science, software engineering, IT curriculum, all the way to a capstone course. We wanted to see the pedagogies that support mastery learning within these sequences of courses, the learning goals that are needed in order to succeed and do a mastery learning in the higher courses in the sequence, and also what assessment looks like and how it's structured in the sequence of courses. And we're focusing within this part on assessment. So what we then looked at was what are the models of mastery learning and how they are implemented through the literature. And we looked at several things. We looked at progression. So that looks at how students would progress through a course and through the model of the mastery learning. We looked at how assessment fits within the model. So this means where assessment is taking place, what does it look like, what is its sequencing, and so on. We were really focused on how support is provided, and in particular for struggling students, in particular when we look at really large classes. Now, I'll give you an overview and some drawings of some models. I think what's important in here is that these are not definite models, and we've seen both like really clear examples of these models in the literature, but also hybrid examples. So I think you can mix and match as is suitable for your course. Oh, yes, and also we looked at the application of these models. So some models, just based on their sequencing, might be more suitable for like an introductory foundational course, while others might be suitable for a higher level course. And you'll see that in here, nothing that I really that I talk about relates to computer science. So I hope this will be useful for a lot of us. So when we look at a traditional learning model, basically we have a series of content, let's say, that is then a series of content and learning activities that is then assessed through an assignment, and then that content progresses to another series of content, and then there's another assignment, and then there's content and assignment and so on. Usually, there is a sequence of assessment items, there's a sequence of teaching, and one would hope that the timeline of the assessment items is tied to the teaching sequence. This progression, though, is set by the teacher. The assessment is varied, and obviously the support is given by TAs. Let's say you're meeting with a course coordinator or the lecturer, and you have some consultation hours. Maybe you're meeting, you have some sort of lecture or some forum. The first model of mastery learning that we've seen is we named it instruction locked, and it's at the end of this I have a link to a paper, and in that paper there's all the references as well. So within this model, there are a sequence of modules, and these modules are sequenced very strictly. And as I said, this is probably the case in your foundation first year courses. The progression is that students are required to show mastery before they progress to another module. So that's what that lock means in there. Students can take these assessments at any time, but if they fail, they must retake the assessment and they come back to the module. They don't progress. So this means that the instructor basically is the gatekeeper. This one, as I said, it will be suitable for a course where you can easily sequence things like this, and also for a course where you have the possibility of and the luxury, I would say, of having infinite time to teach a particular skill, because you're not allowing students to progress until they have succeeded. In the assessment locked model, we're looking at, again, a sequence of modules. The students take the assessment items after the module has completed. The assessment is tied, obviously, to each module, but also sequenced in terms of dependencies with the other assessments. And you can only in here, you can only take one assessment further down the sequence after you've passed the first one. Whereas in the previous one, students theoretically could go in and undertake the last assessment without having gone through the course. The support in here in a mastery learning paradigm looks at providing practice exercises for each module, providing practice exercises for the assessment, and then obviously students will get feedback as they're progressing both through the practice exercises and through the assessments. Now, we've had really rigid models. Of course, we've also seen the what we've called the unlocked model. So in here, the progression happens at any time with the speed that the student with whatever speed the student is going at. Assessments are tied to modules, but they aren't locked dependencies. So you can't, you don't have to do one before you do the other or anything like that. In this model, of course, you have practice exercises for each module as well as before. Now, moving on from these, I think these tend to be really suitable for courses where that sequence of modules is very clear and very easy to define, or concepts or whatever you have. There might be courses though where this is not the case. And in here, I would assume that these would be courses that would be or an example is when courses are in a later sequence within a curriculum. Um, so in here, you might have students needing to acquire all of these skills that are introduced within these modules. There's no sequencing between them, so there's no dependency. Or you might have, depending on your course learning outcomes, you might have a course where you only need a few of these skills in order to get to the next one. So within this sort of sequencing and within this course design, you have each branch having its own assessment, and then you have an assessment item that is locked and that allows progression within the next one. And then the support then becomes as within each branch of the model. We also see within the literature a spiral mastery learning model, and this is for courses that look at having still a sequential progression to modules, but having modules building on each other. So for example, we see this applying very well to capstone courses where or courses right before the capstone courses where you're um, having not only there's a dependency between the modules, but you are, as you're going through, you're building on those skills and you're refining them. You're refining skills that you've dealt with in past modules. In here, for example, looking at module 4, there's assessment 4 that is tied to assessment 1, and students could potentially just take assessment 4 and really not worry about assessment 1 as well. So it will really, though, depend on how you're looking at implementing this. So this is a summary of what we've seen so far. Our current adventures with this work look at providing evidence of the context in which these models work, and also providing exemplars of the implementations of how they appear in the literature, as well as within our discipline. This is a direct result of presenting this work at a conference and having a lot of excitement amongst educators who would like to build a business case to go back to their schools and talk about implementing mastery learning. So our key takeaways from this work is that you can implement mastery learning in a variety of ways, that you can adapt, you can change, you can combine models in any way. And I'm happy to chat about this both today or after if you'd like to. It is not easy though, because we are basically assuming and teaching as well. I would expect students to practice on their own, and there tends to be a bit of procrastination within this space, of course. When one is implementing something like this in a large class, it becomes fairly difficult because there will be different levels of support that would be required for students as they're going through. As with anything, yes, of course, generative AI is a disruptor, but in this particular pedagogical model where we're looking at extensive practice and extensive awareness of one's skills, this is where I think Gen AI is, has the potential to be quite an amazing support tool, but also it's quite could be quite detrimental. On the right in there, you have a quote from one of our students taking one of the mastery courses. Now, before I move on, this is the QR for the paper that covers these, the QR code for the paper that covers these models. I'd like to thank the Leibniz Foundation for supporting the seminar. I also want to say that the Leibniz Foundation provides free childcare for those that are attending the seminar, and also that no told to rowdy kids, as the tone of telling no to rowdy kids sounds exactly the same in all languages, so it's very universal. Now, moving on to the third part of the talk, I'd like to talk a bit about generative AI tools and where we are with our thinking within this and within the implementation of generative AI within mastery learning. I think the potential for automated support with Gen AI is absolutely brilliant, and it is something that we should harness. Similarly, I think we need to think very carefully about how Gen AI perspectives are integrated within the curriculum. I would also like to say that I think generative AI can be very harmful for beginners, and I'll talk a bit in a second about why that is and what some of the studies are saying. And then I'll give you a little bit of an overview of where we are with that implementation. So this is another paper that has come out from that Dagstuhl seminar, and it's talking about the obstacles to adoptions and opportunities for new solutions with when implementing mastery learning, and in particular when implementing mastery learning with generative AI. So when we're looking at generative AI and mastery learning, we can see three main opportunities. The first one is on-demand support and feedback. So in here, you can implement guard-grade LLMs. There's a squillion of tools out there that are offering support and feedback. These ones in particular, obviously, with respect to computer science and programming. And what studies have noticed is that there is the constant availability of a automated support and feedback tool engages students, which is excellent. There is yet no definitive result as to whether having this versus not having this allows students to succeed better in the course, but definitely allows for a little bit more engagement. Of course, we can use generative AI for automated content generation, and this one, you can use we can use it for assessment generation and for MCQs, and for a lot of generation of question banks, which is quite relevant and quite critical when we're looking at a mastery learning implementation. You can also look at using Gen AI to scaffold question generation, depending on the specific skills that you're looking at testing and providing feedback for. This provides an excellent opportunity, if provided obviously that those concepts are sequenced. And also, obviously, we can also look at automated tutoring specifically for mastery learning. So this would require, no tool yet exists, but this would require quite in-depth definition and scaffolding, definition of the skills and of their sequencing and all the necessary scaffolding within that. But it's definitely possible and significantly easier with Gen AI than it was before that. But also, as we are looking at the in-depth or at the adoption of generative AI within our discipline, the skills that we're expecting students to have in order to have a useful, fruitful, and good experience with Gen AI are quite high level. So specifically in here, we're looking at making sure that students understand the code that is generated by an LLM, for example. So that's code understanding, making sure that there is a problem, that students have problem decomposition skills, because um, they are required to be able to take a really large problem and break it down into smaller ones to request LLM support for. And then once those smaller problems are solved, there is quite a dire need for software design skills to bring these pieces of code together. Obviously, when bringing pieces of code together, students would also need to know debugging and code fixing, because they would have to then build up those generated pieces of code. Last but not least, prompting of a Gen AI tool is a critical skill in and of itself. But all of these, they're really high level skills. When we're looking at a beginner focus, we're looking at making sure that our students know how to read and understand code. And this is a critical skill that students don't master very easily. And it takes a really long time for them to be able to really understand what's happening. And of course, then in order to be able to ask something from an LLM and use whatever it is that it's generating, you need to be able to know what to ask, and you need to be able to understand wrong responses. And with a beginner framework in mind, with the beginner focus in mind, that's not straightforward. And of course, there are, beyond the ethical challenges, there are equity challenges as well. And these refer to the ability to and the knowledge to use these tools, which in a beginner setting might not be straightforward. And also, I think, as applies to everything, any sort of subscription mechanism would raise equity issues as well. Lastly, this is something that is definitely critical when we're thinking of beginners developing code and developing programs. When a beginner writes a program and the program is written in the wrong syntax, remember I was talking about syntax and grammar, the compiler, and that's the tool that checks that the program is correct, will give error messages. That compiler for the same errors will always give the same error messages. And although, students might sometimes try to compile something many, many times without changing it, expecting a different answer, the answer from the compiler tools are always the same. And it is through this that then students go and, iteratively fix the errors and come back um, and, improve their programs. When we look at prompting an LLM, the one prompt given today will give a different answer from a prompt given 2 weeks later. And this variability and this lack of repeatability is quite critical. It's quite detrimental for a beginner. So these are some of the things that we need to consider. So what we're looking at currently is a scaffolded approach. And you'll see in here that in that one diagram of the assessment log mastery model, I've put it underneath some assessments in green. I've intentionally not tied them to the model, and I'll talk about that in a second, why that is. But basically, what we're looking at is having in designing an assessment structure where we have assessment items with and without Gen AI support. So specifically looking at building skills, even within a beginner setting, at building skills for code generation with Gen AI. We're looking at having both formative and summative assessment, and we're looking at a sequence of problems of going from simple to more complex problems. This, of course, relies on making sure that we are giving our students opportunities to practice with and without LLM support. And for higher up courses, probably we'll be looking at having a project-based work with Gen AI support and without, and then having students give presentations about the main components of their code. This is very similar to something that Leo Porter and his team has proposed, although this one is looking at CS1 instruction. The reason why I haven't explicitly tied the green assessment items to the others will become apparent in a second. I think in here, first off, before we embark on this adventure, while there are tool supports, as I've shown you for the implementation of mastery learning and for the implementation of the practice of mastery learning. And there are obviously tool supports that support Gen AI. There aren't yet tool supports or integrated tools that will support this, but those I'm sure are forthcoming. Um, the other question I think that we need to very carefully think about is the timeline for introduction of Gen AI within foundational courses. And in here, there's a philosophical question of, yes, we need our students to develop those basic skills that I talked about before they sort of like engage with Gen AI. But at the same time, given its ubiquity, it is critical that we prepare our students for it as well. The other bit is about the assessment scheme and how we integrate the Gen AI skills specifically within the assessment scheme. And in here, I think in order for us to be able to do that in a way that is authentic, we would probably have to include Gen AI skills within the course learning outcomes. And in here, then that would mean the questions then will become with respect to the assessment models in the mastery learning models that we've seen. It will be about where and what do you lock and what kind of sequencing do you enforce and what matters. And I think I'm here in Darwin at the Australian Councils, the Deans of ICT, and we're really talking about the shift from digital literacy to AI literacy. To me, I think it's critical that we have both, but in order to be able to have both, we need to think very carefully about what we assess, where, and what kind of skills specifically we introduce within our CLOs. And with this, thank you for attending today. I'm more than happy, obviously, to take questions now, but also if you want to chat afterwards, and that's my email address, and I'm fairly responsive to it. Thank you.
Thank you very much,
I'll
Claudia. That was fascinating. God, there's so much in there to process. Really appreciate it. Thank you so much. So we do have a couple of questions.
absolutely.
And if anyone else has any questions, please post them into the Q&A window now. First, there's a couple of questions from Jack Badams. Are you there, Jack? I'll ask you to turn on your camera and ask the question live.
Hello.
Yeah?
Hi, can you hear me okay?
Yes, we can, Jack. Go ahead.
I was just I teach math and digital tech, so I believe that approach of mastery learning is something that I've done and works really well. I find it's really like a similarity to the vet sector
Yeah.
as well in that teaching vet courses there is no A to E. It is entirely based on competent, not yet competent, and also it really serves to that philosophy. Could you just tell me what if you're aware of that structure, in what ways your approach is similar and what ways it might be a little bit different?
So if I'm aware about the structure of what the vet teaching looks like.
Yeah.
So I think in here, no, I will say, first of all. But I think I agree that within the foundational programming, um, this idea of either being able to do something and know something or not being able to demonstrate something, I think this is fairly straightforward. To me, it's in the later courses where there's all these beautiful structures sort of like become mixed together and they're not then as as similar to one model or the other.
Thanks. I think the other one is also with mastery learning. Your approach really relies on the student being able to repeat and repeat and repeat and
Yes,
keep trying until they get it
absolutely.
right.
Yeah.
And of course, that is almost the gold standard, isn't it, for educating? We want
Yeah.
every student to be able to have those skills as they progress. I think that the challenge is about the administrative cost, and with
Yes,
CS and
absolutely.
maths,
Yeah.
you can really systematize that. But if you're looking at, say, the humanities, or even where math pedagogy might end up going,
Yeah.
which is more of that interview-based relational sort of assessment, the
Yeah.
teacher judgment, that sort of thing,
Yeah.
where a repeat assessment becomes administratively complex and expensive. How would you navigate those constraints
Yeah.
and still
Yeah.
do mastery learning?
Yes, I have an answer to that. And the answer goes like this. For us, what we've been able to observe, and this is tied a bit to that, reduction in failure rates in subsequent courses. The skills that we develop in these foundational courses are paramount to allow success for students in the other courses that follow. So to me, when you administratively invest a lot of resources in these foundation courses, you're actually reducing the investment in terms of support, and other bits and pieces, drop-in sessions, all the things that we used to have to support students that arrived at those courses and were unprepared. And because you have then control over these courses, then you can design them to the gold standard, and you know how students are progressing through. So in the end, I think it is a cost saving measure, at least for the foundation courses. But the actual numbers would depend on what you're doing. For the others, so for the other courses within a sequence, there are implementations of mastery learning that only look at parts of the course itself. So not like full blown as you've seen in the foundation ones, but maybe just a specific core skill that is definitely cheaper, really. But also it might actually just fit the course better, because there would be courses where within the specific skills, it's only a few that would require this.
Thank you.
All good, Jack? Excellent. Okay, there's a question from Rhoda, my colleague
Yeah.
Rhoda at UniSA. Rhoda, are you there? Are you able to ask this question?
I am here, but
Hi, Rhoda.
I'm walking between buildings. So,
Oh, Rhoda, I can read it. So I think the question in here is about how do we validate student learning, specifically ensuring that students are learning the programming skills and not use Gen AI. Currently in the current implementation is multi-pronged. So first of all, the practice questions that we give to the students, there's a lot of them, and we allow the students to practice on their own. We see students who use Gen AI to practice, and they arrive at the secure tests with a different view of what they think they know versus what they actually know. When that happens and when they don't pass the test, in order to pass the test, they have to get all the questions right. So this is initially it's pretty stressful for students. We talk extensively about the rationale for this and what it means and so on. When students fail to succeed in these secure tests, that is when the support kicks in. So in the CS2 Adelaide University course, they'll meet with a course advisor and talk about the concepts that they haven't succeeded on and so on. In the current implementation, there are specific tailored drop-in sessions and support sessions for students to help them understand what they've missed. And within those one-on-one or one-on small group sessions with the tutors, that's when we talk about generative AI and what it looks like, and the impact of just running stuff through something without understanding what you're doing.
thank you. But I have a follow-up question,
Yeah, absolutely.
Claudia. That practice that the students, ask the students to do, how engaged they are, meaning how, sometimes if it's not assessed, that's when we have a problem, for
Absolutely.
them engaging in those practice.
Yeah. So they are fairly engaged. I think this is a consequence of the tool and the questions and the structure of the course as well. They have weekly sessions where they come and they talk to tutors about their practice. We've been successful, I would say, in making sure that that we really engage and discuss the value of the practice. And of course, also, we don't allow them to sit the test until they've finished a subset of the practice questions. That's the sort of like the stick. But of course, they can put a Gen AI, they can put those through Gen AI and so on. But it is it is really through the training, and that's why Jack rightfully pointed out it's an expensive model to deploy, because it is through the training of the tutors. The tutors spend a lot of time talking to students and getting them through.
Thank you.
Thanks, Rhoda. Jenny Weller Newton has a question. Jenny, are you there?
Put my
Hi,
video on as well.
Go ahead.
Hi, Jenny.
Good morning. I'm really intrigued how this mastering of learning might occur, and I'm talking about nursing curriculum. So we have an undergraduate program, but we also have a graduate entry master's program. So that's a really condensed 2-year intensive program, and we get a lot of international students doing this. It's a smaller cohort, so we have about 60 students in the program, and I'm really interested to see how this mastery of learning might be able to be integrated in, because we have a couple of basic, concepts of anatomy and physiology and pathophysiology, and I'm just trying to listening to you, I'm thinking, how could this maybe translate? And as you mentioned it at the beginning of your presentation about it's been used wisely in STEM, so I'm trying to think, how can we translate this into perhaps, because they really struggle with, they don't often come in without a science background to do this graduate entry master's program. So I'm just
exactly. So this is exactly the setting of our foundation courses. We get students who don't have a background in programming. We're putting them through this full-on kind of course and set of units. More than happy to talk to you, Jenny, about what it might look like. What I'm thinking now, if it's anatomy concepts, what I've seen done is a large number of, automated question banks that allows students to identify a point or order sequence, I don't know, things. You could also do in STEM, it's used quite frequently in computer science and mathematics, but it is a type of exercise where you are giving students parts of something, whatever it is, and then they have to order it. So in maths, it could be you could give them like parts of a proof in all sorts of orders, and then they have to order those elements. In computer science, obviously, it's code. In anatomy, I would assume it would be fairly similar, as would be in any sort of like anatomical systems. This is where my knowledge about how stuff works is sort of like going to finish very quickly. But there's quite a lot of skills that students have to engage when they do this ordering, because they need to understand the functionality and the semantic context or whatever it is that they're looking at, and then they need to understand how it fits. And the benefit of having something like this is that it lends itself very well to automation, because then you could generate a large number of these that then the students can practice on. So that might be one thing that we could look at.
I will reach out to you. And maybe introduce you to a couple of my colleagues who
absolutely
are
more than happy.
Yep. Okay, thank you. I've actually got to dash to another meeting, so thank you so much.
Thanks, Jenny.
And have a good day, everyone.
Thanks, Jenny. I guess we have our last question from Karen Weeks. Are you out there, Karen, still?
Hi.
Hey, Karen, how are you?
Yeah, hi, Claudia. You spoke briefly about AI, Gen AI being harmful for beginners, and you spoke a little bit about them needing to know what to ask and also understanding when they get wrong responses. But can you just talk a little bit more about the harmful effects that it could be for beginners?
Look, I think we've seen in computer science quite a lot of studies, and there are a lot of studies on the perception of students of Gen AI tools and how they're used in coding and so on. There's a lot of studies of how, and within these studies, there is always a part of the student cohort that isn't taking responses from Gen AI very well. And by taking responses from Gen AI very well, I mean because sometimes the thing that the tool generates, let's say when a student prompts for a piece of code, is very complex. It looks even and depending on what they ask, obviously, but again, they don't know what to ask, so who knows what they ask. But it's very complex, and students, when they look at this, instead of going, oh my God, this is terrible. What have I done? Or something like this. It sort of like really affects their confidence and their self-efficacy, because then they think, oh, I'm not good enough. I put this through. I don't understand what I'm doing. I don't understand what it's saying. So clearly, it must be me. There's that. The other one is the effect that I was talking about when answering Rhoda's question is students use it. They get this feeling that they know what they're doing, because they might, let's say, for our practice questions, they might take a piece of they might take the question, put it into an LLM, get the response, put that back into the assessment tool, get a tick 10 out of 10, because that's an automated tool that looks only at results. And then students think, oh my God, I am so good at this. And then they arrive at the test. And within our mastery learning implementation, students have to pass all the questions in that test. And then they fail because obviously they haven't practiced. So that again has the potential to disrupt their confidence and their self-efficacy. So that's why I think we have to be I think we have to be careful in how we introduce them and what we talk about it in terms of its use. I don't think we should shy away from it, and we shouldn't, I think that the times for, at least in programming, for banning outright any sort of use have passed. But yeah.
Thank you.
Thanks very much. So that's all the questions. There was one 8:33. Linda Davies asked, can we please have the link
Yeah.
for the Leibniz
Yeah.
Foundation?
Absolutely. We sure can. I will find it in a second. Shall I put it in the chat?
If you've got it on hand, that'd be great. Thanks, Claudia.
Absolutely.
And as you do that, if we could all show our appreciation to Claudia for a fantastic session and really interesting. I mean, there's implications there for all of our fields, I think, in the way that we do this. And I know at Adelaide University, we're moving to a module format for some of the courses. So this has a huge implication for that as well. So yeah, fascinating stuff, Claudia. And please take our thank you, huge thank you to you, and enjoy your last days in Darwin. We really
Exactly.
appreciate your
Thank
time.
you. I've put the link in the chat as well for everyone.
Okay, so
Thank you.
hopefully you get that, Linda. And just to everybody,
But if not, reach out. Yeah.
the link the link to the recording of this session will be sent out later today or possibly early tomorrow. So thanks very much for being there, everybody. Really appreciate your time, and a huge thank you to you, Associate Professor Claudia Szabo, and we'll see you all next time.
Thank you.
Bye.